Okie dokie. Gonna start some new topics for the second half of the semester. We're gonna do a little trigonometry for starters. Just gonna define a few new commands. And get a little practice with drawing some triangles in standard position and answering a few questions. So let's begin. I want you to compare the length of the opposite side of an angle A to its hypotenuse. And I've got a little diagram up here. Here's angle A, 90 degrees, longest side, the hypotenuse. That's the side opposite to angle A, and that's the side referred to as the adjacent side next to angle A. And I put the words its and its on the side because I hope that everybody knows the difference when you're writing papers, that this one is, it is, okay, and its hypotenuse doesn't have the apostrophe. I just thought I'd mention that. So compare the length of the opposite side of angle A. Here we go, got a triangle. Now I want you to execute that command. All right, and hit the space bar and see if you can. I'm just going to keep talking. Well, before we answer the question, we got to find the hypotenuse. And so here's our right angle. Probably should have drawn that in before. You can stop it now if that helps. But I think you probably know that. So this is triangle XYZ. X, Y, we're in a coordinate system. And I hope everybody knows why that's 5 at this stage. I think I can just write that at this stage. So compare the length of the opposite side of angle A to the length of its hypotenuse. I probably should have written that in to the length of its hypotenuse, but it's late in the day, you know, guy's tired. All right, and so I hope you're writing 4/5. Okay. If this had been a different angle and the hypotenuse was 5, then obviously these numbers have to change. That's part of the study, trigonometry. So just like we did on day 1 with logs, we don't want to communicate that way. It takes too long. So how do I say all of that as a math command? The sine of angle A. If you had seen that, and if I had written that, and you had this picture, I'm hoping you would write 4/5. Now that's a function. And the x in this case is not that x. The x in this case is an angle. Okay. And angles can be written in degrees or some other language system that we're going to talk about briefly at the end of this video. Okay, so what happens if it wasn't the opposite side to the hypotenuse? Well, what if it was the adjacent side? Well, that answer wouldn't have been 4/5. Would have been 3/5. Of course, wouldn't have been the sine command. Maybe you're already anticipating. Cosine of angle A. So if I'd given you the cosine of angle A and you had this picture, I'd hope you would have known to do the adjacent to hypotenuse ratio. And that's all we have. In the parentheses, we always are talking about an angle when we have this kind of language. And that angle produces a ratio. That's pretty much all we're going to be doing. Of course, if I wanted to find out what that angle was, and it appears to be more than 45 degrees because that side's bigger than this side. And this is 0 degrees in this direction. This is 90 degrees straight up. And if we kept going, we'd go to 180 and 270. We go right around in a circle and come back to 360. And we're doing counterclockwise. And we're drawing triangles as we go. And all of the triangles are listed in the computers now. So you can access those ratios. Touch of a button. You used to have to look in the back of a book before. All right, and so there's one more major command, and that's the tangent of angle A, which is actually 4/3, opposite over adjacent side. And those are the 3 commands that we're going to try to get you familiar with very quickly. And I don't think it should take too long. It's not rocket science. All right, and if we wanted to actually find angle A right now, considering that this is a function, right? Then we would do the inverse function, and we would go from the ratio back to the angle. And that in this case would be the sine inverse of 4/5 in degrees right now. We'll just stay in degrees. So if you went to Google and you type that in, you would have to type it with a caret stick. That tells the computer that the next number is an exponent. The computer now knows it's written like that, or it's considering it like that. And then in parentheses, 4/5. And if you wrote the words in degrees, it's probably going to kick something out. My guess, and you can go ahead and do it, is somewhere maybe in the upper 50s, 50 degrees, maybe 57 degrees here. That's my guess. And so I'll later, when this video is over, I'll see how close my guess was. And I didn't put a lot of thought into that guess. But I could have 0.8. I do know some ratios, and it's on the memorization sheet. I know that 0.71, 71 over 100, comes from a 45-degree angle. And I know that 86.6, I think, over 100, I believe that comes from a 60-degree angle. So 45 to 60, I'm somewhere in between. And 4/5 is 0.8. And I'm going to stick with, I'm going to make that lower. I'm going to say maybe 53 now. No, that's more than halfway. 55. Let's go with 55. I don't know. I'm going to have to go to the computer and look. All right. So that's what we're going to practice now. We'll practice doing some of those, and we'll draw our triangles in standard position. And we can do angles more than 90 degrees. And that'll put us in a different quadrant. Let me just start doing it right here. So let's say that x is -2 and y is 4. Okay, so where would that be? Well, that would be here. Something like that, right? -2, your x value, 4. So you'd have to do what? You'd have to find the hypotenuse, 16 and 4, square root of 20. So that's still 90 degrees there, right? But this is the square root of 20. I hope everybody can do that now. I think you can. And so what are the 3 commands? And the 90 degrees is here. Well, I know the sine of angle A. Of course, I'm using reference angle here, right? The reference angle. So that's opposite. And the adjacent, I'm sorry, the hypotenuse is square root of 20. We used to have to rationalize those. I don't care if you do that or not. You can leave it like that. Although we are practicing it, right? I mean, that's 2√5 into 4. So it's 2 over √5. But this is fine for us right now. We're just defining these things. What's the cosine? The cosine of angle, whatever, 115 degrees. I don't know what it is. We'd have to do more work than that. But what's the cosine? -2 over √20. And what's the tangent? The tangent is angle A is really that angle, right? It's the big one, but we're using the reference angle to define the opposite, the adjacent, and the hypotenuse sides. And so the tangent is opposite over adjacent, and I know no one in the room would ever embarrass me by leaving a negative sign in the denominator. So it's -4 over 2, which is obviously -2 to 1. I want to write it over 1 right now because I want you to see that we're going from angles to ratios. Angles to ratios. Okay, that's going to be our mantra for trig, the second half of the semester. So let's do one more. Let's go into the 4th quadrant. X is positive, so let's go. That looks like I'm about 7 units there. That looks like I'm going down 3. And I'm going to have to find that hypotenuse again. And maybe I will actually give you the hypotenuse this time. Let's make that 10. All right, so what do we got? We got 100 minus 70. So we got the square root of 30. I better erase that because it's negative and I didn't leave myself much room. Minus √30, which is somewhere between -5 and -6. Not too bad, -5, not the greatest scale. But can we name the sine of angle A? Well, A is actually more than 270 degrees, but again, we're going to use the reference angle. There's the reference angle. And it looks like I'm looking at opposite is over here. Hypotenuse is there, so sine of angle A is minus root 30 over 10. What's the cosine of angle A? 7 over 10. What's the tangent of angle A? Minus root 30 over 7. Opposite over adjacent. So there's not much more to say about that than to get our practice in class on Monday. And the worksheet, we'll do 3 or 4 of these in a row. Again, I don't think it's rocket science, so I think you'll be able to do it. And where is it going? Just a few things about where it's going. Well, you know, a lot of things repeat. A lot of things out there in the real world are repetitive in nature, and this allows us to study some of those. You know, the temperatures in a certain area during the course of a season. You know, highs and lows, highs and lows. All right, so with practice, we can write these as quickly as we write the equation of a line, and I would expect 3 weeks from now, we will have done enough work that those who are actually looking at it, considering it, and not saving it until the end of the semester, will be able to do that at the end of the semester in 10 seconds or less. Okay, for those of you who don't look at it consistently, you'll be scrambling at the end of the semester to learn how to do this at all. So all you got to do is just watch somebody do it for a few days in a row and then start doing it yourself and then explain it to someone else. And you'll be able to do this. The ability to do this, however, does require an understanding of what are called radian measurements. All right, so let me give you an angle drawn in standard position. And you're used to making that symbol for degrees. But if I kept drawing, oh, it's terrible. That's terrible on my part. Let me try again. Let's see. Okay. All right. Yeah, that's a little better. Okay, so you're used to using that symbol. But if I kept going around, I made a circle. And that little section of the circle is an arc length. And we can define it. And the way we define it is a new unit of measurement called the unit circle, where it doesn't matter the size of the circle. We just define the radius to be 1 unit in length. Just 1 unit. Okay. So what is a radian? Well, it comes from the word radius, but a radius is attached to the center of a circle. 1 radian, we'll use this one, it's the easiest one to see, is, and I think I've got a pencil that's about the right length. Yeah, no, that's not the right pencil. Bear with me a moment. See if I can find that really quickly. There it is. Okay, this is a broken pencil, and I'm going to measure from the gold end, right where my thumb is there, the gold end, because it's just about the same length as that radius. But I'm going to come over here and attach it to that part of the circle, 3 o'clock on the clock. And I'm going to look for that length. And I'm touching it right there, right? But that's shorter than the actual length. So I'm going to back it up a little bit. And I'm going to say that's about 1 radius length. That right there is the same as that. If I did it well. Okay. And I guess my question to you is, how many radius lengths are there? Unit of 1 radius. How many would it take? Because, you know, this smaller radius, but there's still one radius length right there. You know, it's every single one. This is the big one, right? But if I wrap it, it's still going to be 1 radius length. The question is, how many of those are there around a circle? I'd like you to think about that a little bit. Maybe draw a circle, get a little piece of string or something, and you know, that's what you should have done in 2nd and 3rd grade, and I'm doubting anybody does it anymore. So do it now, and then get an idea. And once you do that, and we start talking about that, and that might take you the rest of the semester to understand. For whatever reason, we don't talk about radians enough. And it's very rare that I get a student who actually understands what a radian is. So that's why we're doing it, so we can talk about it for the rest of the semester and give you a fighting chance. All right, so back to this. And your ability to do these equations has a lot to do with radian measurements. So I'm just gonna, I lost my number here. Let me give you a new number here. Let's go 2010. Yeah, I like that. 2010. And what did I have over here? 50, trying to get some simple numbers. Okay, well, it turns out these sinusoidal graphs, which does not mean it's a sine function or a cosine function, it could be either. And we'll be doing both. I think I will write this actually as a sine function right now. It's really all about the heights in the unit circle. And so what we measure off of is a baseline, and that's halfway between 150. So that's 20. Let me change this number to 52. Okay, so the number between 152 is make my brain work. 24 plus 52. 24 less than 176, I think. Okay, yeah, we're good. So 76 would be the y value that we measured from. Where am I going? Up to 100. So that's 24. This is a trig function, sine, which you haven't worked with much, but you have worked with what I'm about to write in that parentheses extensively. All right, so I want to make a 1999. I want to get rid of that number. It's very similar to what we do with the equation of a line, yes. And I'm going to write pi over 2 here without you knowing why. And over here, I'm going to just look at 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And that took how many years? 1999 to 2010, took 11 years. And that's that. Okay, and every number there has a meaning. And you're going to have some fun learning that over time. And this as well. Yeah, that's going to be the hard part for you. You almost already have that just with your work from exponential functions. All right, so that's enough talk from me. That gets us started. And I think that's the first thing we'll do on Monday. Mr. Pillsbury will be with you, and he'll take you through the steps of that again, so you get some familiarity with it. And we're off and running. See you next week.